Now let us go to the next section. So the fifth chapter, yesterday in the fifth chapter, we have completed the first section, which is about troubleshooting. And the next section is about exposing the application. So how you expose the application for external access. So what are the methods through which you can expose the application? So that is about this section. So exposing we already seen. So actually exposing, we have two different methods. One is secure expose and other one is insecure expose. So whatever we have seen about the insecure expose. So we'll learn about that. So in this section, two things we are going to see. So what are the ways to expose the application? So what are the methods available for exposing application at the different levels? So the first level is to expose the application is you can expose through the route layer. So we have two different methods at the route layer, and we have other methods at the service layer. So using the route layer, so we can expose the application. So at the route layer, we have two different methods. So one which is most extensively used in the Kubernetes, that method is called ingress method. The ingress method is most extensively used in the Kubernetes. So this method is also going to expose the application at the route layer. The other method is route method, which is mostly used on the OpenShift side. The OpenShift. So what is the difference between the ingress, the Kubernetes ingress, and the OpenShift route? The ingress, when you want to create any ingress route, the first thing you should have a controller. So there will be ingress controller through which you can able to create a route. So you can able to create multiple URLs for one service. So you can have different paths you can able to generate, backend paths using the ingress. And when you compare the ingress with the OpenShift route, we won't require any controller for creating the route. Route will be created as an independent entity. So there are a lot of options available when compared to the ingress. In the OpenShift route, we have certain security option which is additionally available. So that at the enterprise level, we can have a secure deployment. At the end of this chapter or end of this section, you can see a link. So there in this link you can find the reference link. So there you will find about the ingress, Kubernetes ingress versus the OpenShift route. So this link here you can read about how to create the ingress, how to utilize the ingress, and a comparison between the ingress and the route. Okay. So we are not going in depth about it. So ingress is mostly used on the Kubernetes. Difference between using the ingress and the route is that ingress is a controller unit. You have to have an ingress controller to create an ingress route. But whereas the route we can independently create without any controller. We can able to create a route inside the OpenShift. You do not have any controller. So similarly, if you want to delete the route on the ingress side, you have to delete the ingress controller. Then only the route will get deleted. But here you can directly deal with the route. If you want to modify anything, you can directly deal with the route. In this small article, so they've given about the difference between ingress and the OpenShift route. The important thing to note down is at the bottom you can find a small table. So here, whatever they have crossed, that things are present on the ingress. So whatever things are just empty as black, so that things are not present in that thing. So ingress is having these things, so we can do these things on the ingress. But on the OpenShift route, so additionally we can do these things. These are the things which is related to the secure deployments. So you can able to do these things on the route. So when it compared to the ingress, so the route is most preferred. So at the enterprise level, because you can do the additional secure level deployments using that. You can able to use pass-through method. You can able to use re-encryption method. You can use the split traffic methods to split the traffics according to the different rules. So there are methods available over here. So this is the difference between the, and you can read through this article to know more difference about. There is a example of how to create the ingress, how to create the ingress controller. So there is an example here. You can just go through the examples. You can implement that examples and see how to create the ingress route. And so these are the one way. So where you can, at the route layer, we have the methods to expose the application. Another way, you can expose the application, as I discussed previously, using the service itself. At the service level, so we have different methods to expose the application. So using the service, the first method is using the cluster IP. The cluster IP method is internal. So this is one of type of service which is not used for external communication. So this is for internal communication, you can use the cluster IP. Apart from that, so for the external communication, you can use at the service level something called load balancer method. The load balancer service to, if you have the load balancer, you can connect that load balancer to the service, and so that through that load balancer you can able to directly communicate to the service, and through that you can directly reach the application. So this is a load balancer method. There is another method called external service IP. So this method, what we are doing is, so we have the service. So service, the cluster IP is actually a cluster IP which you are having is a private IP. So the same cluster IP, you can do a NAT, you can do network address translation, and you can convert that private IP to a public IP, and then you can directly communicate to that service. So this is one method. And other method is using the node port, like this is a node port method. So this method is not prepared because by using this method you have to expose one of the nodes, the worker node, so that through that worker node port you can able to communicate to that application. It's a node port method. So that this method is not used since we have to expose the port of the node, so that is a vulnerable, so we'll not go for this method. So but this is also one option available to expose application. Finally, we have something called external name, or you can say CNAME method, the external name service. So using this also you can directly expose the application external to the cluster. So these are the methods available at the service level. Since we are not going for the service level, because service level is not that preferred, because you can use it for small testing environments or small non-prod environments, you can use this. So at the production level, this method is not much scalable. So it's not scalable as well as it's not optimized to be using there. So it's not flexible with respect to the security deployments, secure level deployments like that. So the most preferred method at the OpenShift level is the route. So this is the most preferred method. So these are the other methods available so to expose the application. So you should not think that only the route, using the route you can expose the application. So without the route also you can expose application using the ingress or using the service directly. So these are the methods available. So we are not going in depth about other methods. We mostly concentrate on the route method. Okay. So when you create the route, so there are two ways you can deploy the route. So one way is that secure deployment, another way is insecure deployment. So the secure deployment, so we go for the HTTPS. So we go for the TLS or SSL means of communication, and we'll be using the ports like 8443 or 8080. So typically we'll be using these ports, or you can say 80. Sorry, 80 will not be, so it is insecure. So we'll be using 443 that. So this is a secure method. Another one is insecure. The insecure exposure. So here we go for the insecure one. The insecure one we have to use here HTTP, and we'll be typically using the port 8080 or 80 like that. So these are the two options available for the route. And from the production point of view, so this method is more preferred, like secure method is more preferred than the insecure method, because any client is going to prefer the secure deployments or the secured way of reaching that application or securely exposing the application. The insecure way, we are not going to prefer it unless it is an internal environment or it's in some non-prod or testing environment. We can prefer this method, so we can avoid the overhead of having a secure deployment. But unless otherwise, so as of the production is concerned, so always you have to go for the secure method. So always is going to prefer the secure way. of reaching the application. So we'll see how to implement this. So what are the methods available for implementing this? So we'll understand some basics about the secure communication. So what is the secure communication means? We'll understand some basics. So from there we'll build the secure, we'll do a secure deployment of the OpenShift application. So the secure application is where the secure deployment, we have a server, this acting as a TLS server. So what it will do is initially you will do a handshake. So once as a client I'm going to communicate to the secure server, initially the handshake happens. The handshake, the client and the server is going to exchange the hello packets. So after exchanging the handshake, the hello packets are exchanged. Then the server will issue the certificate to the client, and client will verify the certificate, whether this certificate is a globally digitally signed certificate or not. So the client is able to verify that. Typically the verifying agent will be the browser. So our browser will verify that certificate validity and the signature. So once it is valid and verified, so the client will issue the encrypted key. So it will encrypt the session key to the server. Then the normal communication between the client and the server takes place. So this is what the TLS communication happens. So we'll go and check that in an elaborated way. So normally, for example, if you are reaching any site, so any typical site, if for example, take an example. For example, if I'm reaching the Google site, so Google server, I'm reaching it. The Google server is a secure server. So you can see on the top left side, you can see on the small lock symbol. If you click this lock symbol, you can check the validity of the certificate. You can check the certificate. You can see to whom it is issued and who is the issuing authority, and what is the validity period, from which time to which time it is valid. So you can see the certificate here. So this is a digitally signed certificate. So when I type in the google.com and I try to reach that site, I don't see any warning, because the browser at the back end, it is verifying that certificate. So the certificate is verifiable. So the browser is not showing me any warning or safety precautions takes, because the server is secure server. So this is happening at the background. So what is happening here? So initially, you can check that in the command line. So here you can open up the command line. In the command line, you can try to reach this site and see what is happening there. So I can just curl. So curl this HTTPS google.com. When you call this, you can see the initial handshakes between the client and the server is happening. So here you can see the TLS handshake. So the initial client hello, server hello, that takes place. Then you can see here it is issuing the certificate. Here you see the country name, the state name, the region, the organization to whom the certificate is issued. So the certificate start date, expiry date. You can see that certification verification is fine. So these things are happening. So at the command line level, you can able to see this. What are the initial things is happening between when I try to communicate between the server, when the communication between the secure server and the client takes place. We can see this. So once everything is fine, so finally the handshakes are completed. Then you see the actual data. You can see the actual data over here. And this is what the secure communication is. So here you can see. So initially, so my server, when I want to convert my server as a secure server, I get the CA certificate from the globally verifiable or global authority. So who can issue that certificate? So I'll be paying for them to get the certificate, and I'll implant that certificate on my server. So when the client is accessing, so when the client is requesting identification, I will issue this digitally signed certificate to the client. The client browser will see whether it is the CA certificate, the certificate authority who issued that certificate is verifiable or not. So it should be verifiable in all the sense, like the digital signature should be verifiable. Then the validity period of the certificate should be verifiable, so that the client browser will verify that. So after verifying that, then it will send the session key. So start the communication, and the server will acknowledge that back. Then the secure communication, now the encrypted communication between the client and the server takes place. So this is the basics behind the TLS communication, or you can say secure communication. And at the OpenShift level, so we see the communication flow from the router to the service to the endpoint, to the application. And we have three different methods depending on which location is acting as my TLS server. So two locations can act as my TLS server. The first location is the router itself. So this router itself can act as a TLS server. So if the router is acting as TLS server, we have one method. And if my endpoint, if that is acting as my TLS server, that is another method. If both the router as well as the endpoint is acting together, so it is acting as one TLS server, then again it is acting as the endpoint is acting as another second TLS server, then we have a third method. So depending on how which is acting as a TLS server, we have three different methods. So here we have the OpenShift cluster. The client is accessing the cluster. So when the router issues this TLS certificate to the client, so we are going to place the certificate in the router, so that whenever the client is reaching the cluster, the router is going to issue this certificate to the client. The router is going to act as a TLS server, and the client will verify the certificate and all these things. So if the certificate is verifiable, the client is able to access the application securely. So this method is called edge termination. Since we are calling it edge because the router is at the edge of the cluster. This is the starting point where my communication starts inside the cluster, or you can say it is my edge point. So from where I'm entering the cluster. So it's called edge termination. Another way where my endpoint, so this itself, the endpoint, the application itself, not my router, only my application itself is acting as a endpoint, like acting as a TLS server. So here the application itself will issue the certificate to the client. So here I have to place the certificate and all the details inside the application itself. So this method is called pass-through termination. So I am bypassing everything. So directly the application is issuing the certificate to the client. So that's why we call this pass-through method. And there is a third case where both my router as well as my endpoint together. Now here it is a separate case. Only the router is acting, or my endpoint is acting as a TLS server, or if they act together in a combined way. So TLS certificate will be issued by the router as well as by the, so it will issue one certificate and the endpoint will issue another certificate. This method is called re-encryption termination. So I'm re-encrypting the information, like I'm encrypting with one certificate at the router side. So this scenario will be applicable in the real time, like the platform management team. So they can issue a certificate to the client. They can issue their own certificate, and the application team. So one who is taking care of the application, they will issue a certificate to the client. So both the ways the applications are more secure. So this is called re-encryption. So I'm encrypting in one way, and again I'm re-encrypting at the other end. So this is a re-encryption. This will be the most secure way. So because we are using the two different certificates to encrypt the communication, but this method has like a lot of overhead. So if one place it is failing, the other will be gets affected. For example, the router certificate expired, but the application certificate is still valid. Still the application will not be reachable. So reachable in the sense not be reachable securely. Insecurely it will be reachable, but like in a secure way it will not be reachable. So that has a overhead. So we have to see that there is a proper communication between the client, proper communication between the application team and the platform team. So the operation team who is maintaining the platform, so that both the certificates are in sync. So these are the three methods available. So we'll go to the book and read the definition of that. So here, so the methods for managing the traffic is we can have two methods at the route level, so route and ingress, and at the service level we have load balancer, we have external IP, we have node port, we have external name, we have additional methods at the service level. And for creating a route, for creating an insecure route, we normally use the expose command. So this will just create an insecure route. So we don't have to use any certificates or that kind of stuff. But when you want to expose the application securely, we will create that route. And here, for securing the route, we have three different methods as we discussed. One is the edge termination. Here in the edge termination, what happens is the TLS termination occurs at the router before the traffic is routed to the pod. So this is what the edge termination. The pass-through termination, the encrypted traffic is sent straight to the destination pod, straight to the endpoint, without the router providing the TLS termination. So this is what the pass-through method is. So which we have discussed here. So this is the pass-through method. And the last one, re-encryption. So re-encryption, here the router terminates the TLS certificate, and then again the re-encryption action happens. Like again the re-encryption happens to the connection with the endpoint, which might have a different certificate. So the re-encryption happening over here. So it is re-encrypting the communication. So this is a more secure way. So these are the things. So in our curriculums, we will see the two methods, like the first two methods, edge termination and the pass-through termination. So once you understand this two, this will be easy. So we are not separately covering this re-encryption. But once you know these two methods, so you can easily understand this third one. It's like a variation of these two. When you combine these two methods together, that's what the re-encryption. So we'll focus on these two methods in this section. So here you can see in the edge termination, so this TLS certificate and key are placed in the route itself. So you can see that application is not having that. So up to this, communication is secure. Once they cross the route, so the communication is insecure. So internally it's insecure. That's fine. So client will not worry about that. Internally it's insecure. So because internally most of the cluster environment will be secure environment, so no need to worry about that. But the client will not know about it. But client will be seeing the secure communication. And in the pass-through, you can see the certificate, the same TLS certificate and the key are placed in the application itself. So here it's not placed, the application is independent of that job. So here the route is having that, but here the application itself is having that certificate, and the application is going to straight away issue to the client. Like when the client accesses, this certificate will be issued to the client from the application itself. So the client will be having that certificate issued from the application itself. So this is the pass-through method. This is also a secure method. So we are going to place the TLS certificate and key in the application itself. So this is the second method. So this is what these two methods will cover in our curriculum. So how to deploy this. And now let me just take a. I think my screenshot is not required. So we'll see steps for configuring the pass-through route. Before going through that, we have to understand one more thing. How to generate these certificates, because when you want to create any secure routes or secure server, you want to deploy a secure server, so you have to generate the certificates and keys in real time. What's happening, what's the procedure to generate the certificate. So any organization who want to have a digitally signed certificate, what they'll do is they will generate their own public key pair, they will generate their own private key. With that, they will generate their CSR. In the CSR certificate signing request, they will mention about the company requirement, like company details, like what is the organization name, where that is located, what is the country, what is the organization which is associated with that. So what is the common names, what is the expiry date. All these things will be mentioned in the CSR, certificate signing in request. And this will go to the root CA, the certificate authority. So one who can issue a digitally signed certificate, which will be globally verifiable. So anybody who is opening that, anybody in the globe who is opening that server, so who is opening that, who is reaching that server, that browser, so through which browser they are reaching, that browser which will be able to verify that certificate. So that's what a digitally signed verifiable certificate. So that authority, what they will do is they will internally generate the key pair and certificate, and they will issue the certificate to the client. So they will issue the digitally signed certificate to the client. And the client server, they will implant the certificate on their server, so that whenever their client is accessing that server, this certificate will be issued to the client. So So this is the procedure which we have to follow. So in our classroom environment, so we cannot able to generate a globally digitally signed certificate. So we will generate a self-signed certificate. So we'll not able to generate a digitally signed certificate like we'll generate a certificate which is self-signed. That means if this certificate is issued to the client, we'll see that we'll see a warning. So we can ignore that warning, but the concept is that we have to see the mechanism. So whenever the client is reaching my application, we should see that the client is getting the client is seeing the certificate. Client is seeing that certificate is issued from the server. So in our case, it's not a physical server. In our case, it is a containerized application. Okay. So I'll take a screenshot of this. For reference. Okay, now we'll go and discuss how to configure this pass-through route. So what are the steps we have to follow to configure this pass-through route? So first we'll discuss about the pass-through route, then we'll discuss about the edge route. Okay, so how to configure the edge route. So what are the steps to follow to configure that? So here we'll build a scenario. So we'll have here cluster 1 minute. Okay, so here I have here the OpenShift cluster. So inside this, I'm going to create a project. Let me say this project is my demo 5. Inside this, I'm going to deploy an application. And this application, which I'm going to deploy, is a secure application. So it is going to work through the secure channel. This application is called PHP SSL, the PHP SSL based application. So I'm going to deploy this application. And first thing I required before I deploy the application, so I need to have the TLS certificate and key. So I need to generate this TLS certificate and the TLS key. So I need to generate inside this project, because I required this to get inside that application. So I required this one. We will generate this one. This will be the first step. We have to generate the certificate and key. So once you generated this one, you will be injecting this into the application. So later on, you will generate this as a secret. Later on, you are going to inject this into the application. Because in the pass-through method, whatever we are covering the pass-through termination. So in the pass-through termination, so you need to embed the certificate inside the application. In the pass-through termination, we need to embed the certificate inside the application. So that we are seeing the pass-through termination over here. Just 1 second. We'll just run some large set of commands. Okay. Now we'll start. I'll just provide this as a guidelines. So how to configure, what are the steps. Exactly this step is not required. Like you don't need to follow exactly as this step. You can interchange some steps as per your requirement. But I'm just following a generic steps here. If you want, you can interchange the steps depending on your requirement. No need to follow exact steps. You can interchange in order to follow. Here first step is to create the TLS certificate. So I need to create the TLS certificate and private key. That's my first thing, because that is a primary thing. So when you want to create any secure route, so I should have these things, certificate and private key. So here I don't have a globally verified authority, so I don't have any C authority to provide me that certificate. So I'm going to self-generate myself. So this is called a self-signed certificate. So when you issue a self-signed certificate to the client, so the client will throw you like a warning. So anyhow, so we need to see the mechanism. So we don't worry about the warning because this is a learning environment, so it will not be followed. But in the real time, so that should be issued by the globally verifiable authority. So like we have different authorities for issuing it, like VeriSign, GTS Global. So we have different authorities who can issue that certificate to the client. So we'll generate that. So this you have to do in steps. The first step is to generate the key. So I will create the project. So anyhow, I'm going to do this in the local system. So this is not relevant, but anyhow, I'll create the project. On safer side, I'll create the project my demo 5. So it's a new project, my demo 5. I'm creating it. So on the local system, I'm going to create a directory. The directory I'm going to call this CRT. I'm creating a directory. I'm going into this directory. So I'm going to generate that files inside here. So the certificates and key, all this information I'm going to generate over here. First step is to generate the private key. This is the first step, generate the private key. So I'm following this steps, but I don't have root CA, but these 3 steps will be same. So instead of this happening at the root CA, this will happen here itself at my same organization itself. So I will be generating the self-signed certificate, but the steps remain the same. First I will to generate the key pair, then I have to create the CSR, then I have to create the certificate. So first I'm generating the private key. So using this OpenSSL command, OpenSSL, to generate RSA. So there are a number of ways to generate it. So I'm just following this generic way to generate it. So you can use different ways to do it. There are a lot of things, parameters you can keep on adding to make it more secure. So I'm going to just keep it very simple here. So here I'm going to say the name of the key. So name you can give anything. So I'm going to just match it to the application, and this, since it's a PHP based application, I'm going to call this as php.key. And here I'm going to say the encryption size, encryption algorithm bit size. I'm going to say this is 2048. So I can say like any size to that, make it more secure. Now you can see now the private key is generated, which is there in this directory. That is the first step I have to do. The second step, I have to generate the CSR. CSR stands for Certificate Signing In Request. So here I need to provide my certificate information. So because whenever the client is issuing the certificate, you are able to see that this information. So once we were seeing that, like you can see that when the certificate issues to the client, you can see the subject. So you can see the country, you can see the state, this is the region, this is the organization, this is a common name. So you can see that. So this information I'm going to provide that through the CSR. So CSR will give a way to provide this information. So I'm going to create a CSR now. The second step, I need to generate the CSR. CSR is a certificate signing in request. So here I'm going to use the same OpenSSL command. Again, I remind you that there are multiple ways to do this. Okay, so in the book they may follow different method. I'm just making it very simple. So just so that I just create the essential thing. So I'm not concerned now with the security. So if you are concerned with the security, you can add multiple parameters to that to make it more secure, the certificate to be more secure. But here I'm just keeping it very simple. Okay, so don't think that this is the only method to generate it. There are multiple ways to generate the certificates and keys, and make it more secure. You can add multiple parameters. You can add multiple like pause and phrases and all these things you can add. But here I'm just doing it very simple here. So I'm going to create I'm going to request I'm going to generate a new CSR. Here my key will be, so the signed key will be, which is already generated, which is php.key, and here I'm going to mention my output will be so php.csr, which I'm going to generate here. And finally I'm going to generate the subject. So subject, here you have to mention the country name and all these things. I'll just get a sample file. From there I'll just get the subject. From the lab file I'm going to just get the subject. So instead of typing that, just I copy from here. You can type it just to avoid some typos. I just do that. So I'm going to get this subject from here. This is used for a different example. I'm going to get it. I'll just use this just subject alone. I'm going to get it from here. So here the subject, I'm going to change the common name. So I'm going to match this common name to my domain address, which later I'm going to get this route. I'm going to say php dot apps dot ocp folder, which is my wildcard domain, ocp4.example.com. I'm just mentioning that over here. So this is a certificate. So here C represents the country, ST stands for state, L stands for the region, O stands for the organization, CN stands for the country common name. So with that, you can keep you can add multiple other parameters also, but I'm just giving this information, and I'm creating the CSR. Now the CSR is locally generated in my system. This is the second step. The third step is the creating the certificate. This is my third step, the generate certificate. This is what ultimately I need. So the final step, I need to generate the certificates. So this is so whatever I'm generating, this is a self-signed certificate. So I'm signaturing myself. So this is a self-signed certificate. So it cannot be globally verifiable. It is just self-signed by me. So if you trust it, you can use it. Otherwise, you cannot use this one. So generate self-signed certificate. So here I'm going to use again the OpenSSL command. OpenSSL. The certificate type which I'm going to generate is X509 type. So here I'm going to mention the required number of days. Here I'm going to give the expiry details, like the certificate expiry time. I'm going to mention it should be valid for 1 year. I'm going to say the number of days. I'm going to say it should be valid for 1 year. I'm going to say 365 days. For the days I'm saying 365. Then I'm going to mention my input here. For input for this one will be the CSR, which I've created in the previous php.csr, and the out for this will be the output which I'm going to generate will be php.crt. This is the certificate which I want, and then the sign key, so signature key which I already generated, which is php.key. So I'm mentioning this information. So I'm going to generate the certificate. So this certificate will be self-signed. So you can see now the signature is okay. The certificate is now created with the subject. You can see the country, state, and all these things. Now these are generated. Now at the end of this one, you can see now I have the certificate and key. So now I just require these two things. I required the certificate and the key. CSR is not required. CSR just it's an intermediate step to create the certificate. So the CSR is not required. So only I required the certificate which will be issued to the client, and also the decrypting key. So I can say the private key to decrypt that certificate. So only those two things are required to create that secure route. So now I created the pre-requirement. So I have created the certificate and key, and what I have to do is I have to make it as create this as a secret. So now I have created this one locally in my system. So I want to get this inside the OpenShift. So this is a sensitive information. So when you want to get any sensitive information to the OpenShift, so you have to create that as a secret. Okay, so I want to create this secret, and here I'm going to create a secret called TLS type. The secret type will be here, the TLS. I hope you remember in the chapter number 4. So we have different secrets. So one is generic. So we have Docker registry. We have the TLS secret. So here the secret which I'm going to create is TLS secret, because the nature of the content is TLS information. So I have to create a TLS secret. So I'm going to name this secret as php-crt. I'm going to name this secret as this php-crt. So I'm going to create this secret. So because I need to inject this secret into the application. So in this application, so I'm going to inject into this volume. So later on I'll be doing that. So I'll be injecting this inside this /etc /local /usr /etc/local. Then I have to mention the SSL/CRT. So you can place anywhere, just I'm placing it here. So I will later on inject this into this location. The certificate need to be injected here. So I need to inject that as a secret, so into this location. So that's what I want. So I need to create this secret now. So that will be the second step. So you can interchange the steps, but you can deploy the application first, then you can create the secret and inject that secret in the application. You can interchange the steps also, but I'm following this step here. So I'm going to create a TLS secret in the project. So I'm going to create the TLS secret using these entities. So I'm going to currently I'm in the project, my demo, or you can verify that. Verify. So I'm going to create OC create secret. So now the secret type. If you see the secret type will be like, we have 3 types of secret. Now I want to use the TLS type. So I'm going to name it as php-crt, name of the secret. So here the secret is going to come from the certificate. So certificate name followed by the name of the certificate, which is there in my local directory, which is php.crt. So the certificate name, then the key, decrypting key or private key to decrypt that certificate. So I'm going to provide that key, which is php.key. So this is what I require. So this information I'm creating the secret. Now the secret is created. Now we can view the secret. You can just OC get secret. So the name of the secret will be php secret, and you can just view that in the JSON or YAML format. Now you can see the information. You can see the key information. You can see the certificate. You can see the key. So this is now I created this one as a secret entry. Now it is into the OpenShift. So whatever the entity which I have created in my local system, I have imported that entity into the OpenShift as a secret. So this is there. So now whenever there is a requirement, I can fetch this secret. I can mount this secret into my into the application or somewhere wherever it is required. So now I've brought in this entity into my OpenShift. So we have completed the second step. The third step is to deploy the application. So during the deploying the application, so I have to take care of the facts. Like I have to see, I have to customize some information. So for example, I'm actually mounting the secret into that application location. So I have to specify that. So I have to specify the secret name, and I have to specify the port, which port the application is getting exposed, what image I'm using for deploying the application. So all these things I'm going to specify. So I'm going to follow the declarative architecture. So I'm going to have a declarative file. So I'm not going to write the file entirely. So already have the file. So I modify some facts, which I want to customize. I will modify that facts, and using that I will deploy the application. And I am going to use specifically the image from the QA registry. So I'm going to use that PHP SSL image. So here you have this image. Using that image, I'm going to deploy it. So even though I'm going to use the image to the declarative file, so I just need to know the path. I need to know the tag. So what tag they have used. So I just use Ctrl F and use PHP. This is the image which I'm going to use, PHP SSL. So this is there under this training/PHP SSL. So this is the image which I'm going to use, and I want to check the tags. So it has got 2 tags. So I want to use the tag version 1.1. The reason for using that is 1.1 is secured and 1.0 will be insecure. So I'm going to use this 1.1 for secure deployment. So here I'll come out of this directory. So already I have the declarative file in this location as a part of a lab. So here I have the file, which is PHP HTTPS. This file, using this file I'm going to deploy it. So there is a definition for the deployment. This file has got two definitions. So one is deployment. So through the deployment, I'll have the replica set pod and the rest of the things. And also I have the definition for the service, which is needed for this external communication. I require this service for doing load balancing. So you have the definition for the service in this file. So when I create the resource, two resources will be created. One is deployment. Through the deployment, other resources will be created ultimately, and the service will be created additionally. So here I need to customize some information. Here I'm going to change the project name. So this is the namespace. I'm going to say this is going to be my demo file. So I'm deploying this on my demo file. I have to mention the project name here. And replicas, all these things I will leave as it is. So here I have to set the container image. The container image. So I'm getting it from qa.io. So I'm getting this from image from here. So I can copy this. Okay, so here I have to mention the version. Version should be version v.1.1. Just restore it back to here. Sometimes you press colon, it will just displace this one. So restore it back to that original position. Then I have to provide the container port. The container port which I'm going to expose this application, I'm going to use a secure port, which will be commonly 8443, the port which I'm using here. And I'm going to mount the information. So here you can see the mount path. So I'm going to mount that secret inside this. So I have to mention, so once you are deploying this application, it is going to look for this secret information inside the path, inside my application. So you can use here the secret name, the secret which I have created, which is php-crt. So this is what I want to mount. So as per our scenario, you can see I want to mount this certificate which I already created into the application. So I need to mention that name here. So once I deploy this application through this file, so I already mentioned this name. So what this deployment will do, it will look for that secret. If the secret is there, it will mount that secret inside this file system, so inside this mount path. So this is the one way you can do it. So I am doing that in the declarative file itself. So there are other ways. So during the class we have discussed in the morning when we were discussing about secrets. There are other ways to do that. So you can use this command. If you're not declaring that in the file, there is no definition in the file, but you want to inject that information to the file, you can use this command. So you can see OC set volume. So you say the deployment name, you say the secret name, and you say the mount path. So where you want to mount that secret. So we know the secret name. Secret name in our case is php-crt. We know the mount path. The mount path is this one. So I am declaring that mount path inside this file itself. So if it is not defined in the file, if you want to define it later on, then you can do that. So you can mention this mount path in this command, and you can inject that secret also. That's another method. So here I am doing it in the declarative file itself. The file itself I am defining all these things. So that I don't need to do any external work. So immediately when I create this deployment, it will look for the secret, because I already mentioned the secret name inside this declarative file. It will look for the secret. If the secret is there, the application will run. If the secret is not available, the application will not run. The mount point, it will not able to mount that secret. The mount point will show a mounting error, so the application will not run properly. So you see that you have created that pre-required secret. So I'm going to save this file. The other things are fine. So at the service level, I don't need to give anything. So other things are fine. The service port number will be 443. So it will be linked to the target port, which is my container port, which is 8443. So I'm saving the file. So using the file, I'm going to deploy the application. So at the moment, I don't have any application inside this namespace. So I'm going to create it. So now I'm going to create the deployment. So once the deployment is created, we'll have the replica set. Through the replica set, pod will be created. Through the pod, container will be running. Then the service is also, the service definition is also there. Service will also be created. So I'm going to create OC create -f. I point out to this file php-https. I'll create this now. Now you can see two things created, deployment and service. And now you can see as a result of this, now it has started creating the container. So after some time, it should go into the running state. So once the container is running, what we have to do is we have to verify this information. So you have to verify whether this TLS certificate is available in this location. So this is what required, because when the client is accessing this application, this certificate should be issued to the client from this location. So I should make sure the certificates are available here. Okay, so I have to ensure that fact. So to ensure that fact, I'll just get him straight away into the application. So I just do cat php APS. Here we have actually mounted in this location. So now what I will do is I'll do OC RSH remote shell. I'll get into the application PHP HTTPS. Then I'll get into this. I'll just list in this path. Once I list it, you can see inside this path, you can see the certificate and the key, which is mounted. The mounting information I have given in the declarative file itself. So here you can see the volume name. This is a volume mount. This is going to mount inside this volume, and you can see that. So if you do df-ht, you can see the mount information. You can see this is mounted in this certificate. That is the volume name, and this is coming from the information for this volume is coming from here, from this secret, so which you already created, which is a TLS secret. So it is getting mounted here. So this is, you can see this information. You can see this to certificate and key. So we are verifying that fact. Now we are done with the step number 3. So we have successfully deployed the application with the pre-required steps or pre-required things. So now we have done the 3rd step. Now the 4th step, I need to create the pass-through route through a specific container port. This is very important because the port is, because I need to communicate through that particular port. I have to mention the port in the service itself, in the route itself, so that it's going to communicate through that port. I need to create this pass-through route. So here I'm going to create the pass-through route. So I need to mention the port. The port for this should match with the container port, which is 8443. So this is the container port. And always when you are creating a route, you will create for a service. So service is already created. The name of the service which is created during the declarative file. You can get the name. The name of the service is the PHP HTTPS. This is the name of the service. You can look at the name. So this is the name of the service. For this service only we are going to create the route. So I have to mention the service name here. The PHP HTTPS is the service name. So now we are going to create the route. So once you create the route, what happens? So in the cluster, so we have that project. Inside the project, we have the router running. So we have OpenShift ingress. We have the ingress project. Inside this project, the default router is running. Default router. So that will have the publicly resolvable DNS or public facing IP. And once you create the route will have an entry in this router. And what happens? The client is actually going to reach this route. The client is going to reach this router on the client side. So once the client is reaching, what happens is through this route, so this will be our path. It will reach this route, so it is going to go through the service. this service will be reaching to this application. So this will be the path. So once the client is reaching this application, so what happens is this certificate, which is over here, this will be issued to the client. So this certificate, which is over here, so this will be from here. This will reach the route. So the certificate from here, it will go through this router. So this will be issued to the client. So straight away it is going to issue to the client. And here the client will have that TLS, the TLS certificate and key. So this is what the pass-through route is. So this will be issued to the client. So this is what we are going to observe. So now we will create the pass-through route. So that is a step number 4. So we'll create. So here I'm creating it. So when you don't create the route, you simply expose. So if you use the command expose and expose the service, so you are creating an insecure route. So when you do like create a route, when you do create route, you are doing something as secure route. So we see create a route. So we have 3 options. So the option is, one is edge, other is pass through, last one is re-encryption. So I'm going to use this third option, which is pass through method. So pass through. So always we are going to create a route for the service. So I have to mention the service name. So the name of the service is this one, HTTP PHP-HTTPS. I have to mention the service name. Then I have to mention the port. So which port I'm going to use it. So the secure port will be 8443. This is the container port. And I have to mention the host name. So this is optional. If you want, you can do it. Otherwise, you can leave it. You can go with the default. Otherwise, it will get the default DNS entry of the service. I'm using the PHP dot the apps dot OCP4 dot example.com. Okay. So now I'm creating the route. So now the route is created. Now you can see the route, OC get route. And now you can see that route. Now the route is created. Termination type is pass through. Now when you do OC describe route, the name of the route itself, the name of the route is PHP HTTPS. And describe the route. You can see this URL which I have generated is exposed on the router default. So this is what the client reaches. So it is exposed on this. There's an entry for this route over here. So the route is, which is the local entity on my project. So this URL will have entry on this router, so that the client is reaching the router. So it will redirect the request to the service, and service will redirect to the particular application. You can see now this is exposed on the router default. This is exposed on the endpoint port, which is 8443. So here you can see the termination type, which is pass through, and you can see the service, and you can see the endpoint. So now I need to curl this. So I just do OC get route. So we have done the fourth step. The final step is to test the application. So test the application from the client end. So here the same OpenShift client machine I'm going to use as a client. So I'm going to use the browser. So what you're going to see now is that you should see that mechanism. So it is going to issue me the certificate. The certificate will be issued from the application itself. And here you're going to see the warning. So as the certificate is issued to the client, you will see the warning, because the certificate which is issued will be the self-signed certificate. So you're going to see that warning. So let me go to the browser. Open this. Here I'm going to use this URL. So I'm going to do testing so that I see that the certificate is issued or not. So here I have to do a secure route, so this should be HTTPS. This should be HTTPS. Now you can see the warning. Now you can see the potential warning. It's saying that security risk ahead. Why this warning is coming? You can go to the advanced and analyze that. You can see the warning is coming because the certificate is not trusted, because it is self-signed. We know that fact. Like we generate the certificate, self-signed certificate, and you can view the certificate. You can just give your view, and you can see the certificate which we have generated. The common name, the organization was Red Hat, organization unit. We didn't mention that, so we see the organization name and the common name. The expiry date we are given 1 year. You can see that 1 year calculated from today. So all these things you can see the certificate information. I'll close this, and I will accept the risk and continue. So this is a local environment, so it is no problem. So I will accept the risk and continue. And once I accept the risk and continue, you can see now. You can see the results. You can see this. I'm reaching the application. And here you can see that on the log symbol you can see a warning, but any of this is almost a secure communication. So you can compared to this one which we have generated previously for the WordPress, so this communication is not at all secure, like it's insecure communication, because it's not issuing any certificate or nothing. So this is an insecure communication. So here it is a secure communication. So you can see the log symbol which indicates secure. Only problem is the certificate which is issued by the client. Which is issued by the server, which is not verifiable, which is a self-signed certificate, so that I'm seeing this warning. So this is what the pass-through termination. So the pass-through termination, as we have learned, so the application certificates are we are embedding into the certificates, and these things are we are embedding into the application itself, so that the application is issuing the certificate to the client. In the pass-through termination, you can see we are placing this Tls certificate and key in the application itself, and this issues to the client, so they can say that's complete pass-through termination. This is a pass-through route. And second way, second kind of termination is edge termination. So in the edge termination, so what happens is we are placing the certificate and key in the route itself. So we are not placing it in the application. So we are placing it in the route itself, and we have to say that when the client reaches, so the router will issue the certificate. The router will have entry for the route. So in that entry, so you will have the certificate and these details, and this certificate information will be passed on to the client, and the browser will try to verify that information. If it is globally verifiable, the client will be able to access the application securely. So in this method, the application is doing nothing. So application is not having any workload here. So only the router is just issuing that. So in this method, we take off that workload from the application. The previous method, the application was taking the workload of acting as a TLS server. Here now the router is going to act as a TLS server. So we'll see the steps to configure that. The first steps almost remain same. So we have to generate the key, we have to generate the CSR, and we have to generate the certificate. These steps almost remains the same. And let me now deploy that here. So we'll create a new project. So OC new project. I'm going to say this project is my demo 6. So I'm going to create a certificate and all these things. So let me now create a directory. So I'm going to create in my local system, get a directory, the certificate 1. I'll go to this FTU1 and get into this directory. So here first I need to generate the private key. So just to save time, I'm going to use that. I'm going to use that same command here. So here I'm going to change the name only. So here I'm going to say instead of PHP, the application which I'm going to use is Nginx application. So you're going to see some output like hello Nginx. So I'm going to call this as hello. So hello.key. That's I'm changing the name of the key as a hello.key, which is generated in my local system. The second step is to generate the CSR. So second step to generate the PSR. So I'll just repeat that command again. So here I just change the names. So other arguments remain as it is. Here I'm going to call this as hello.key. So here I'm going to call this CSR as hello.csr. And in the subject, I leave other things as it is. I just change this common name. Instead of PHP, I'm going to call this hello. Everything is customized value. So you can give any names or any common names you want. Just I'm sticking to that. Just I'm giving the name which is matching the application. So I'm creating here hello.apps. As a common name. So now I've created the CSR, and finally I'm going to generate a certificate, self-signed certificate. So here also I'm going to use the same, or you can say just use the OpenSSL. Here I'm going to create the certificate type, which will be X509. So here I'm going to request it for number of days. So I'm going to say this is for 365 days. So 365. And then I'm going to say that my input will be php.csr, and my not php, it should be hello.csr, and my out will be hello.trt certificate. Then my signature key will be hello.key. So with that I create a self-signed certificate. Now I have everything in place to create the secure route. This time I'm going to deploy the application. Now because the application is independent of this information, so previously I have to deploy the application, I have to place that application, that information inside that application. So now here there is nothing required to create a secret or we can directly place this information inside the route itself. So now I'm going to deploy the application. So for deploying the application, I'm going to use a specific image from that same Red Hat training. I'm going to use a specific image from here. So here I'm going to use a Hello Nginx image. So I'm going to use this Hello World Nginx. So I'm going to use this image. So let me check any tag is there. It doesn't have any tag, so it is the latest tag is there. So I'm just going to use this image. I'm going to deploy the application. So I have everything, pre-required things I have created. Now let me deploy the application. So now I'm in the project. Always you have to verify on which project you're working on. So now in the project my demo 6. So I'm going to create OC new app. So I'm going to say hyphen name of that application. I'm going to say so this is Nginx. You can say anything like a hello or Nginx. So I'm going to say the Docker image. The Docker image, I'm getting it from here. So I'm going to deploy this application. So now the application is created. So now we should wait for that application to come up and it should get in the running state. So once it's running, then we can place this. So now the service and everything is created. So now we are going to place this certificate details, like place this TLS informations on the route itself. So during the when you are creating the route, that time itself you are going to place this information. So here you can create that as a secret and also you can get it from the secret, but here I'm directly doing that. So just to save some time. So if you want to do that secure way, you can create that as a secret. Previously we did it. So here I'm just directly going to place that information inside the route. You can create that as information as a secret and then you can place that information over there also. So you can, here I'm just directly going to place it. So now the application is running. Now I'm going to see the services. So this is the service name. So I'm going to create a route. So we see create route. So the route type here will be, so we have three types. Here it will be edge type, edge termination. And here always we are going to create it for service. The service name is Nginx. And I'm going to mention the certificate. So here the route itself, I'm going to mention the certificate. Certificate we have created already, which is hello.crt. And I have to mention the key. The key which I have created, hello.key. Then I have to mention the host name. So the host name, I'm going to say hello.apps.ocp4.example. .com. I'm creating this route now. You can now see OC get route. So the route is created, and you can see the route is having edge termination. And you can look into the route now. So OC get route. If you look into the definition of the route file, OC get route. Name of the route is Nginx. So -o YAML. If you look into this route now, you can see this route has got the information. It has got the certificate, and the key information is available in the route itself. You can see this kind is route. In the route itself, we have placed this. You can see this is a route. So in the route itself, we have the certificate. Sorry, I got disconnected. Yeah, I'm creating the route over here. So this is there. So now I can curl through this route and use OC get route. So if I curl through this route, So even though the port is which is here is 8080, this is a TCP, like this port is normally used as insecure port. Since the application is exposed over that port, so I can use some application which is having the specific port. Still I can able to communicate to this, so I will not have any problem with that port over here. But if you want, you can declaratively create an application with a different port like 8443. So using that you can able to do it. So here just want to see the simple here, because application has no relevance in this thing, because my routing point will be the router. So router which is going to issue the certificate. So the application has no relevance in that one, because application, because here if you see the communication, only from this point to this point is secure, like from the router to the client. So this point is secured one. From here to here it is insecure. So inside the cluster it is insecure. So the port number doesn't affect anything. But here the port numbers are concerned, because here it is directly you're using the application using that port number. So that port numbers are thing. So when you look into the inside the cluster, for example, if you are communicating, you are breaking in the communication from service to the application, you will see that there will be insecure communication. So you will not see the secure communication here, but here you will see the secure communication. So the port number doesn't make any issues here, because my communication starts, the secure communication starts from here. So the port is starting from here, so port will not be any problem if you are using 8080 or 8443. But if you use 8443, it will be better. If you are using 8080, it's not an issue. So here I'm going to now just call that location. I'll just copy this, paste it, and here I'm going to use here HTTPS, and you can see now it's also issuing the certificate, but now the certificate is issued from the router. So you can see the certificate details. Since it's a self-signed certificate, I'm getting a warning. You can see the common name and the validity period of the certificate and all these things we have created. And you can go and check this application. You can accept the risk and continue. You can see now I'm reaching the application. So for the client, this seems to be a secure thing. So client will be okay, because he doesn't know where which is acting as a TLS server. But for him, he will be satisfied that yes, this communication is secure. But internally, we know how this is working. So if you look into this means, here for example, when I do an internal communication, for example, when I get into the service, from the service, if I try to communicate to this application, you will see that the communication will be insecure. So for example, if I do OC, I get into the node, so OC debug, node like master 1. So let me get that service name. Service will also get service. Here I'm going to debug command. I've used debug command, node master 1. So I'm going to reach this application using this service address. So I'm going to do a curl. I'm going to use the port number 8080. I'm going to reach it. Now you can see I'm reaching it. So this is insecure. So I'm not using HTTPS. I'm able to reach it. The application is reachable. This is internal. So internally, internally it is insecure. So that's what in the H termination, that is the disadvantage, that internally it is insecure. So when you're reaching that application internally, so there will be no verification, because the certification is issued from the edge, so from the router itself. I'm crossing the router and reaching the application. That time it will be insecure. But the second case, where here it will be completely secure. Even if you try to reach it from the service, you will see that the communication is still secure. We can verify that fact. I'll go to that previous application. I'll go to the previous project where we have deployed that pass-through route, which was in the my demo 5 project. So here, if you try to get the service, so service name, this is a service name, and here I'm going to get into the node OC debug to the cluster. So from internal to the cluster, I'm doing this. The node which is master 1. Any node I can get into it, and I'm going to do a curl. So here, if I try to reach this through this 8443, sorry, it should be 443. That's our service port. So I try to reach it. You can see that I got a message like your browser request. You're talking to a server which only understands HTTPS. It doesn't understand HTTP communication, because even if you tap in between, the communication is secure. Only you can reach it through the secure means. You cannot reach it the insecure means. If you try to reach it, if you do like HTTPS, you can see that now I can try to reach it. But the problem is the certificate problem. The certificate is not a verifiable certificate. So if I want to ignore it, I have to use here -k and I have to reach it. So only I can reach the application through the secure means. So that's why the port is very relevant here. So this port is important in this thing. So here the port is not important like in the previous one, because I'm reaching inside this, it's insecure anyhow. So even if you have a secure port, so it will not be a benefit for me. So the port is, that's why it's not relevant in case of edge termination. But in case of pass-through termination, the port is very important, because the port I have to do an end-to-end communication. The port is mattering. The port number is very important. Okay, so with that we come to the end of this session. So we have completed the second session of the 5th chapter, is exposing the application for external access. So one more session is there. I think now the time is already up. So we'll see this session tomorrow morning. Okay. If possible, tomorrow if we can start by 9 o'clock. We are still lagging in the curriculum. So if possible, join. Okay, so we can start a little bit earlier tomorrow. Instead of 9:30, we'll start by 9 o'clock. Please, if anybody have issue, just please let me know.